Okay, so let's get started. We have our last programming assignment in front of you, and I'm going to go over this one real quick, and then after this, I might cut the video in two actually, so when you watch it, you can see this programming assignment review, and then the next part will be the next lecture. So what you're looking at is the last programming assignment, which is actually doing less than, well, it's about a week, I would say. No, 2 weeks, because next Monday, if you remember, we all voted last time, and you have your final exam review, and then we still have class on Wednesday. And then we have the final exam the following Monday, July 2nd. So you still have a couple more weeks, so you can pull this one out actually pretty easily now. After you've done the dinosaurs, this one is a piece of cake, because you already know about the inheritance part. So you're just doing another inheritance exercise with a slight twist to it. And the twist is you actually have to stick, and you've already done this, if you did the data structures one correctly and you created objects of stock and you took those objects of stock and you stuck them inside of stacks and queues, you've done this already. The twist on this one is you take the objects of the people and the employees and you stick them in an array. And you have to go through the array and you have to see, is this a person or is this an employee? Is this a this and this or that? And lucky for you, the last time I taught this course, I reused the same assignment. It had a different assignment number to it, but I saved the video, and I'll show you where that is. And or I practically, if you pause the video, you can actually write the code down. I practically wrote the assignment for you. So I don't have to reinvent the wheel here. Instead, I can just show you where the video is, and then you can see where the help is. But let me go over the assignment first, because you need to know what it's about. We are writing, and it says ITU wants you to write some classes for a personnel record system. So to make it, you have 4 classes you're going to write, and here's a picture of the classes right here. You've got a person. Everybody's a person. You have an employee, and then you have a student. Of the employee variety, some of the employees are janitors, some of them are instructors. Well, there's no janitor on here. All you have to do is create an instructor. But theoretically, you'd have other types of employees as well. People that worked for ITU, I should say, that weren't students. So, I don't know, the situation in which you have a student who's an employee probably would not be able to be represented in this diagram. But you don't have to worry about that. Just, mimic this as much as you can. So the following picture illustrates the relationship between the 4 classes. So the person is the parent class of the employee class, and the student class, the employee class and the student class, and the employee class is the parent class of the instructor class, as we've seen. So this is just like the dinosaurs. Here's Dino, and here's all your different varieties of dinosaurs. Except you're going 3 levels instead of 2. You should know how to do that already, just using extends. So the following are the tasks that you need to complete in order to create these classes. You create the appropriate fields for each one of the classes for each class, and necessary fields are listed here. You may add anything you want. You're not going to really need to have to, but you can add. You can basically change it around, make it as customized as you want. But at a minimum, the person should have an ID and a name. The employee should have a salary because it already has an ID and a name. And a teacher already has an ID and a name, so it needs a teacher ID and a teacher name. And then the instructor needs a student ID array. So the instructor is going to have an array, and so instead of using and if you want to use an elaborate data structure, you can take something that you created out of assignment number 4 if you wanted to, for example. If you already have a working stack or a queue that you like, you can actually use that if you wanted to read, but that's a harder way of doing it. So assuming that you're not going to reinvent and you're just going to create a regular rolled array, you'll be loading objects, instances of objects in the arrays. And so the student, yeah?
You said the person ID to be unique.
The person ID should be unique, yes. And how do you set that? By making it a class variable, by making it static, yeah. So if it's static, and in fact, if you go over lecture number 1 or 2, I hit that stuff right there. In fact, this example is in one of the beginning lectures of this course. So, in fact, I used to have this one earlier on in the assignment set, and it was like the first or second assignment. Only problem is that I had that little twist with the array, and it, caused everyone too many problems too early in the course. So I saved it for last this time, but you pretty much, we're going to see this example in the lecture from the earlier part. So let's see, yes, this one should be unique. It's a static, so it's going to be a static. In fact, it gets incremented automatically when when the class is used. So the instructor has a student ID array, and this is the array of student IDs of this particular instructor. So you set the ID or size to maybe 10 initially, set them all to 0 if you want, assuming the instructor won't have more than 10 students. If you're not familiar with arrays, this is your opportunity to learn them. If you want to know the pros and cons, here's one of them right here. Once you set the size of the array, it stays the same size for the entire duration of the program. It's statically bound, it does not grow, even in Java. Same thing happens in C++ as well, or C. Which is why we have those abstract data types, the stacks and the queues and the lists and all that other stuff, because arrays are okay, but they're sort of lightweight. They're not really a huge data structure. They're more of a way of just keeping more than one of the same type of object or primitive data type together under the same name and using index values essentially. So if you're not familiar with the concept of array, let's look it up. You're going to need to use it for this assignment. All of the above are private. So all of the data members are private. And this particular exercise, I like it actually because it's the last assignment. So when you read this stuff, you're going to be like, what? I already know all this stuff, which is great. Because then hopefully you'll have a feeling of accomplishment because you know all the fields or the data members should be private at this point and that the member functions are public, and hopefully you remember the static part. There's also a toString method that you can use on each class. In fact, we saw an example of the toString method. It actually comes from object, and it's the ability to print out information. So it's a toString method. If you missed any of the previous class meetings, you can go back and take a look. At the lectures, I did sort of covered that already. So a static find students array method in the instructor's class is going to be used to fill up the instructor's objects of student arrays. And then we have the corresponding student teacher IDs. I've done this for you in a video. So if you want to, you can watch the video and I'll show you where to get that. And it's going to do it for you. Or you can try it on your own and then check it out. Check the video out afterwards. But the reason why you want to do it static is because you're going to do it at the class level. Because what you're going to do is you're going to create a bunch of students, you're going to create a bunch of instructors, and then after everything's done, you're not working with the objects anymore. Now you're at the class level working with those instances of those objects. If you create a static method to put them together, then you can run it right there in main. You can say, okay, all you students, what are your ideas? What teacher do you belong to? Find out your teachers. And there's a lot of looping with that because you got to go through the array and you have to find out all the students, give me your teacher IDs. And then for each one of the teacher IDs, so you have a loop nested inside of a loop, because for each one of the teacher IDs, you have to say, okay, we have student number 1, he goes in this one, 2 goes in that one, 3 goes in this. You have to assign the students to the teachers to populate the teacher arrays. The teacher arrays to populate them with the students, so the teachers know about which ones, which students are assigned to them. So you have provide multiple constructors and methods if needed. What constructors you do provide is up to you in your program design. The person should be declared as an abstract class. So this is kind of reiterating the abstract class concept. In fact, this assignment has really got everything in it. All of the different pieces that you've hopefully have worked with so far. The parent class and the constructor use the super to call to reduce the redundant code. So you're going to super back to run their constructors. Make sure that the test.java file can work with your classes. See the sample output below, which from the sample output you'll have some information about each one of the specific objects that you'll print to the screen. And note that the sample output is not the unique output format of the test program. So the real output format depends on how you design your toString, what it is you decide. You don't have to follow through this example completely identically to the output. You can create your own output. So hint, there is no main method in any of the 4 classes, only one, the test class, has the main method. Make sure the ID is unique across the objects, so you declare it as a static class ID in the person. I show you that actually in the example as well in the video. And read the instructions in the test.java very carefully for better understandings. And so submit your, in fact, I'll show you where those files are in a few minutes. So submit everything in a zip file. And down here on the bottom, I give you the test program. So don't fight the test program. If you don't like the test program, change it. If you don't like the way it's doing something, feel free to edit it. You don't have to work with the test program as is. It's just written for you to give you an idea about what it is you should be doing. So it's more of a guideline. And this is Lab 2. Well, it's actually not really Lab 2, it's Lab 5. It used to be Lab 2 in this class. I didn't change that. But you could change it if you want, or you can leave it. With the main method, and here's person P, which is equal to new person George, as an example here for testing it out. And basically, these are examples of how to make the arrays. The arrays of the objects can be made out into the test program, like this is doing. Inside of the class, you would have an array of objects for teachers to keep track of students. You could also put something in students, although it wasn't asked for in the assignment, to keep track of teachers, if you wanted to. But you don't have to. So if you look at the code here, you'll see there's a student named Peter, there's an instructor named Peter, and you see we can have the same name because the student IDs are always going to be different because people IDs are going to be different. So as long as you keep the people IDs unique, you can keep track of it by the people IDs. So here's a student named Tom, and his instructor is Peter. Long story short, if you go through and you read through the code, it'll give you some examples. The sample output sort of looks like this outside of the green squiggly lines, and these are line numbers. You're not going to see any line numbers print out on your screen. So instead you're going to see Peter's a student, Peter's an instructor earning salary of this. This is what the sample program will print out for you. So it'll print out, Peter's a student, Peter's an instructor earning a salary of 0.0 with 1 student in his class. And so here we have student 0, which is 5. Sandy's instructor earning a salary of $25,000 with 0 students in her class. And this output here is being system out. The ID and the name of the person in the array is being printed out this way. So if you run through the example, you'll see how the test program, you'll see how the output is actually created. Before I switch to the example files, are there any questions about the general overall description of the assignment? You can always send me an email as well. Do we need to do that? Or you can ask me next time as well. Do we need to do this? Do we need to do that? So let me shut this window down and show you where you can find this lovely video I've been promising. The lovely video. Have you seen the video? Yes. Oh yes, it's lovely, isn't it? Not only does he totally give the assignment away, he totally gives the assignment away, doesn't it? Yeah. See? Testimonial right here. She's already watched the video. She'll testify that there's no mystery to the assignment after you watch the video. I don't know if that's a good thing or a bad thing, really. Actually, let me get to the correct spot first, and then I'll make it bigger. So let's see, in the object-oriented programming class, if I go into the assignments, I believe it's under the assignments link, which is going to be in course materials. Assignment number 5. So here's the test.java program. That's the one that was in the assignment description that's showing you essentially, a classic kind of test. And here's the sample output that's also in the assignment description. And here's the how-to video. Let me just make sure the link works. Did I put the code underneath it? No, I didn't. I think I did it on purpose, although I did pause the screens, I think.
Actually, I was asking for the assignment 4 now, not for the assignment 5. So I was looking for the assignment 4 examples.
Oh, okay. Well, the data structure's in there too. Here we go. So if you pause the video, you'll see the source code, actually. I don't provide the source code because then I would be giving you the assignment. But video does a really, in fact, I went into way too much detail, I think, because I pretty much, on this particular one, I pretty much gave the assignment away. But you can see we have instructor, which extends employee, and if you go through the video, you'll kind of see how the entire project is put together, and then you can kind of mimic it yourself. At one point in the video, I believe I also scrolled through the code and paused it, so you could copy it off the screen if you wanted to. Feel free, if you want to, you may do that. It takes longer, I think, to do that because the video itself is 1 hour and 11 minutes. So probably too tedious to do that. You might just want to watch it and maybe create the assignment at the same time simultaneously. That might actually be a good way of doing that. Take you an hour to do the assignment, probably, maybe 2 hours. Practically everything. Look at it. This is the code right here for the last assignment. In fact, here's the array. You pause it right here, actually. Here's the find students array. The static method that you need to put into main with this nested loops I just talked about a few minutes ago. After you create all of the objects, you can populate the arrays for the teachers so that you can find all the students. So it's really meant to be an exercise, not less like, for example, it's not supposed to be a test. So that's why I can kind of give it to you, but in order to do it this way, you're going to have to spend an hour of your time looking at this video in order to do it this way. But it is pretty much the entire assignment done for you. So it's an option you have if you can't do it on your own. It is the last assignment, however, and so, probably it's going to be, definitely it's probably going to be the last thing you're going to work on, maybe, who knows. And so you do still have 2 weeks to do it, so it's not necessarily that time consuming either. So, alright, I'm going to pause this or stop this video unless we have questions on the assignments. Okay, good.